Hey guys, it's the September 2025 and here is an update from the X-MEM 80 project, a 512 KB page memory extension for the TRS-80. Now the Model 1 version is already final and was published on GitHub last week for everybody to build themselves, right? And so here's the Model 3 version, and you see it's currently running the MEM test program from Anytech, and SuperMem mode 32 KBs pages with X-MEM 80 here, and it's being tested, and you see it's doing fine, right? So we have like 512 megabyte, half a megabyte plus the internal memory reported here. So some progress here. My TRS-80 Model 3 is fully disassembled here, and here you see the X-MEM 80 card, right? And providing 512 kilobytes of paged memory in SuperMem mode that we just saw the test program using, as well as some software that is available for the SuperMem mode, such as LeeScript and so on. It is using 32 kilobyte pages, but there's also a jumper here for 16 kilobyte pages, which is the mode that I actually intend to use, or I am using that for MIDI data for the MIDI 80 card, right? And yeah, so what can I say? It's the first version of X-MEM 80 that I designed didn't work, so this is why you see the botch wires here. And so when I plugged it in, it didn't work, right? Well, it worked to the extent that the TRS-80 was working, but I could not access the upper 32 kilobytes at all. So the upper 32 kilobyte memory wasn't detected at all. And so I even, then pulled all the installed upper to 32 kilobyte DRAM chips here, right? That didn't make a difference. So in principle, you don't have to pull them now if you install X-MEM 80. And so the issue here was that the original version that I designed, theory of operation was that it would simply rewrite the memory request as well as the I/O request signals basically for the TRS-80, right? So signal going in here, basically CPU generating memory requests, I/O requests, and then the rewritten version would go back into the TRS-80 basically, so that only the lower 32 kilobyte and I/O addresses not for X-MEM would get into the TRS-80 motherboard, right? Turns out that this was not sufficient because there is still one transceiver basically on the Z80 data bus, right? And this is U90, and you see that my workaround for this was then actually, to lift the enable pin 19 of U90, right? So this is the chip here under the, in this region here, you can see it, it's covered by the X-MEM 80 here. But with this hack and then, adding another glue logic chip here, a NAND, so I need 4 NANDs in order to basically strengthen the enable signal, because this chip basically is only disabled on the TRS-80 Model 3 motherboard if the ROM is being accessed, right? Otherwise, the chip is acting as a transceiver, which the direction can then be changed to input-output mode, right? Based on the memory read and write requests, basically, as well as the I/O requests, of course. So this workaround here then of mine would have required a pair of botch wires, basically, right, going into the U90 chip, right, lifting the pin here. Thankfully, this chip was already socketed on my motherboard, so it would have been a solution. And it actually worked with that and also detected. So the memory test here ran as well. But so that's actually not what we then finally did, right? So thanks to Mark Pruden or Kiwi since birth, basically on the TRS-80 Discord, we found an alternative solution, and this is what's implemented here. And the nice thing about this solution is that it does not require botch wires into the TRS-80 U90 chip, so it's simply a CPU plug-in board and no further modifications to the TRS-80 motherboard, or pulling U90 and lifting a pin are required for that. So very nice. So that works differently. Basically, rather than rewriting mem rack and IO rack, this is now shared between the Z80 and the Z80 Model 3 socket, and rather we are rewriting the read and write signals, right? So that basically this is what's being modified, and being like a man in the middle basically on the Z80 control bus is that's what's happening here. So basically that the read and write requests for X-MEM and the upper 32 kilobytes are handled by X-MEM 80, right, by its 512 kilobyte SRAM chip, and only the lower 32 kilobytes and IO requests for the Model 3 that need to go onto the motherboard are being forwarded into the TRS-80, right? So this is how that works now. Very beautiful solution, and thanks to Mark or Kiwi since Spurs to to persuade me of this. Even though I was skeptical at first, I really thought that the only way of achieving this was to disable basically in tri-state U90 on the motherboard, which turns out to be not the case. So I'm very happy that I was wrong there, and that this solution seems to be fully working. So we can also show you one more demo here. For example, play back a large MIDI file, right? And also show you that I/O and all the other hardware is working. So here we are loading 4 32 kilobyte segments now into the banked upper 32 memory range, right? So even though the MIDI files, the segments here are only 16 kilobytes each, it is using the 32 kilobyte pages mode, the SuperMem mode. And so it's loading here from my GoTech, and in a bit we will be able to listen to the song. So that's basically the same software that's running for the Model 1 version, now also running on the X-MEM Model 3. And for the playback speed, let's use 4. And then you can hear that MIDI 80 starting to play back. Alright guys, so much for that. I have already sent off the new version of the PCB Gearbus to JLC-PCB, so I will have a version of X-MEM 80 for the Model 3 without requiring trace cuts and botch wires on the X-MEM board next week, and then I'll post one more update, and then the GitHub the sources and Gearbus, the GitHub is going to be updated as well. Until then, thanks for watching, take care, and happy September.